Hello and welcome to another session of Me Programming Daily. Thanks for joining me again today. I'll be working on drakon renderer. And today I'll just continue what I started yesterday, and that was to represent drakon diagrams slightly differently using simpler types and using more general types. So yesterday I came up with this block type, and it's two of its flavors. We can either have terminator blocks or skewer blocks. So my plan for today is to add some examples of skewers or letters that can be letters and maybe words even that can be put in skewers and just flesh out this design a little bit. So I did some reading yesterday, and I finally know why this wouldn't work. So to the best of my understanding, if you've watched the session that I posted yesterday, I struggled a little bit with showing or providing implementation of show for a terminator block, and that was because I defined it like this, meaning I provided just a new data constructor for this type constructor block, the data constructor being terminator. So if you take a look here, this terminator and this terminator, they share a name, but they're a different type, and well, a different thing really. This terminator is a type constructor for type A, and this terminator is data constructor for type B. So if you do show terminator here, it really is referring to this one. So it has no way of knowing that you really are interested in the show implementation of this terminator, right? So this is why the resolution is to provide a new data constructor for this type constructor, wrap up this type in this data constructor, and then you have access to instances of that type that are bound to the variables t. And yesterday I learned, after so many years with hobby Haskell, there's always something to learn, and it sounds like an obvious thing, but I just never use something like that in practice. I very rarely build new types and complex types with Haskell. So if you didn't know, now you know. All right, so let's show the the drakon white paper. And here we have some examples of words, and in this case, words are here. Here we have drakon letters. So now we have to, or rewind. Yesterday I gave some examples of terminators, and according to the documentation, we can only have 5 different types of terminator: title, cyclic start, and these two. And we have that represented. However, skewer blocks are slightly different, and according to the documentation, a skewer block, well, so at this stage we should all know what the skewer block is. It's a building block that has one entrance and one exit. And looking at letters, meaning figure 1, letters are candidates from numbered from 5 to 8 and some more. So we're just going to add them here, just the same way as I added a terminator. And again, I'm not looking for perfection right now. I'm trying to build a bigger set of building blocks for drakon and see if patterns emerge. And if they do, we'll try to generalize and the cycle will continue. So I have you have your coffee or tea or whatever ready, and let's get to coding. So we're going to borrow what we've done with the Terminator. And here we have a first problem, because skewer block is what the documentation defines, skewer block. And here, so technically this type should be called a skewer block. So it means that we'll have to rename this. Let's leave a comment that this should be renamed. However, we can start providing some data constructors for skewer blocks. And these are headline. Let's just double check. Single entrance, single exit. Address. Action and shelf. So apart from shelf, I can already recognize a lot of familiar or many familiar icons, aka letters, like headline, address, and action. We already have these implemented, just slightly differently. Now, looking at the documentation, also icons from, or letters from 10 to 17. So that's a choice. Case. Oops. I'm just taking these names literally. I'm not trying to make any changes. Output. And, so we have to take everything up until icon 17. So input. Pause. So that's 17. Period. That's an interesting one. We also need to add 19, 21, and 22. Parallel process. And comment. And these are comments. It's a loop arrow, silhouette arrow. But also, drakon words 4 to 21 in figure 2 are examples of skewer blocks. Okay. So let's not worry about words yet. Let's only focus on letters. This is good enough. And now here, let's rename it. Instead of blocks, let's say diagram block. So that works now. We just have to rename their instances. And then skewer block. Let's just use X. For now, let's not worry about the show instance of this. Block. Yep, it's a diagram block. Oh, yeah. Oh, yeah. And now we construct this a little bit differently. So say we just do an action. And maybe it's still not the most elegant thing, but I can already see a pattern emerging. A pattern where a diagram is just a 1D list, because that's what it is, where some blocks will be I'm not sure recursive is the right word, but some blocks will contain nested and chained words and letters. Let's see if it builds. It should. We'll get to clean all this soon. Let's format. Okay. Now, let's do a bit of cleanup. Thanks to HLint. This X will keep because soon enough skewers will have their own implementation of show. So even this is redundant. Okay, that's good to know. So now, if we run this, nothing should change from yesterday. Perfect. So now, I think the next reasonable step would be to provide an implementation of the type class show for skewer blocks. It's going to be very similar to this. And and let's make a few changes here. Instead of using just an abbreviation or just a single letter to describe instead of using just one letter to describe a letter or an icon, let's use the full word. Or a combination of words. Almost there. Insertion. Did I miss this? What is that looking like? Insertion. Okay. The reason I'm interested, insertion is another term describing the act of putting something into a valence point or replacing a valence point. I didn't realize we had an insertion letter. These will not be shown yet. Just wanted to check if it builds. Okay, perfect. So this does not look like a drakon diagram, but what we can do now is supplement these with some lines. So I'm thinking maybe not only lines, but like a visual block for all of these terminators and actions. Maybe that would be a good idea. Oh, why not? So a visual block will take a string and it will return a string. And that content. Okay. So it's like this. And the closing line we'll add a little bit later. So we need an odd number of these dashes so that we can say 1, 2, 3, 4, 5, pipe, \n, \n, 1, 2, 3, 4, 5, pipe. And that should provide a nice visual representation for a wrapper. Around a block. So let's try this out with these two. I forgot this. So we're only doing terminators now. All right. This is not looking too bad. Now let's implement the closing pipe. But after we add the visual block between these. So what I'm thinking is the sort of litmus test of my new idea for representing the diagram is that if console-based layouting is relatively easy, the more visual SVG-based layouting should also be easy. Okay. closing pipe. We're going to use a fold L. That will be or maybe not. Let's use a list comprehension. So what I want to do is I want to inject only the correct number of spaces required to place the closing pipe. I think we'll need a helper function for this. Let's call it spaces. And that would be limit so if spaces limit is 0, this doesn't matter. Return an empty string. If the limit is non-zero, we get a space added to result of spaces so we don't even need this content. All right, and that redundant bracket here. Close. We also need to remember about this opening pipe and the space. And oh yeah, and we need to leave one extra space for the pipe operator, or the pipe symbol. Okay, this is looking well. Now, but just as with spaces, let's call it this function fill, and let's give it a character. Sorry. Let's see if we can just do a character and this. Now it should be this. So here, fill with spaces. Sorry. With spaces. And here, fill .11 with the dash symbol. And the same will apply here. Oh, sorry. And spaces is also used somewhere. Fill. Okay. That is not correct. Oh yeah, it's backslash in. Okay, this is looking good. Oh, but let's not forget title and end do not have an entrance and an exit, respectively. So let's provide two implementations of it, one with no exit, one with no entrance. Okay. Let's see if I'm using the right terminology. Terminator has either a single exit or no entry, so it's an entry, not entrance, entry. So if there is no entry, we can remove this guy. And if there's no exit, we remove this. And we can see that a bulk of all these three functions can be reused. Let's call it visual block core. The content is going to be this. Oh. Content. Now we need to actually apply it. So no exit. So terminators will all change. So let's open the documentation. Title and cyclic start do not have an entry. Let's see cyclic start with parameters. Oh, these are actually words. But again, they don't have any entries. And does not have an exit. Okay. This is what we wanted. Let's just make sure that we have this 11 as a constant. Let's maybe change it to 15. No more 11s. There's only 15. Okay, let's run it. Yeah, perfect. It's a little bit longer. let's see if we can compose other things with it. So let's take some of these longer names. And parallel process. I hope they fit. No. So 15 is not enough. Let's do 20. So that looks good. Just double check. Title, action, begin, end, parallel process, action, end. So now this line is not perfectly in the middle. I don't necessarily care, but here. So it's this is incorrect. It should be fill. For now, I'm just replicating how it works now. Fill 5 spaces. We'll change that 5 very soon. Oh, yeah. Oh, yeah. Okay, we still have that 5. Now, let's replace that 5 with I think this is good. Oh. Would mod be good? Oh, sorry. Yeah. So this doesn't have to be 20. And 21, it can be 20. Oh, that's not. Let's see. It's not much. Div. Perfect. That's what I wanted. Perfect. So that will be okay. That will look much better. Perfect. So I think we made another step. So time to probably wrap it up for today. And next time, I'll probably look into adding more words here because we already have words here. And also, maybe we'll start looking into representing these more complex structures. Like, for example, a fork. We can probably start gentle. So a fork would end up generating something here. Okay. Okay. So I think this is good enough for now. I'm looking forward to tomorrow's session, though, where we'll be fleshing this out even further. And we should be attempting to position icons tomorrow. Yeah, pretty excited for that. Right, having said that, thank you very much for your attention today and for sticking with me. And yeah, I'll see you next time. Bye-bye.